Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends, to your younger brothers and sisters, and to your friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies as part of your preparations to engineering life, then please don't forget to subscribe. So let's have transformation equations for moments and product of inertia. So in the preceding topic on moment of inertia of areas, we learned that the values of I sub x, Iy, and the product of inertia, this time I'll use P sub xy for product of inertia, are affected by the orientation of the origin. So we simply use the parallel axis theorem or the transfer formula for moment of inertia of areas in computing the above moments of inertia when the origin is translated to another point. This time, we vary the orientation of the origin by rotating the coordinate axis so that we can develop expressions for finding the maximum and the minimum moments of inertia associated with point O, and find the orientation of the corresponding axis relative to the original coordinate axis. So we consider the plane area shown, and let us rotate the axis so that the UV set of axes will pass through point O. So we have here the UV axis, and let's consider a differential area on the region. So the rotation of the UV axis is denoted by theta, and it is counterclockwise in this manner. And take note that UV axis still pass through point O, and that's the differential area dA. So by the way, the objective here is to find expressions for the moments of inertia with respect to the UV axis in order to determine the value of theta for which moments of inertia will be maximum or minimum. And later we call this maximum and minimum moments of inertia as principal moment of inertia of areas. So we have here the original distance x. This is y with respect to the xy axis. So that's x, that's y, and we draw lines parallel to the u-axis as shown, and this angle is also theta, and this is u from dA to the v-axis is u, from dA to the u-axis is v on the other hand, and this is also theta, the measure of that angle. Then this is y, and because this is theta, therefore the length of this is y times sine theta as shown. Then we draw line parallel to the v-axis. This distance here, because the hypotenuse in this right triangle is x and that angle is also theta. So therefore this is hypotenuse x times cosine theta. Then this vertical distance here is x sine of theta, while this distance here is this leg of this right triangle, 90 degrees here, is because this is y, the hypotenuse, parallel to that. So y, and the angle here is theta, therefore this is y cosine theta. This is y cosine theta, and this part here is x times sine of theta, which is equal to this, x sine of theta. So therefore, from the figure u, this is u, is equal to y sine theta plus x cosine theta. So u equals y sine theta plus x cosine theta, while v, which is this, or this part here, This v here is y cosine theta minus x sine theta. Then moment of inertia with respect to the u-axis is equal to integral of v squared dA. So I sub u equals integral of v squared dA of area, and replace v by quantity y cosine theta minus x sine theta quantity squared dA. And take note, we have here cosine squared theta integral of y squared dA, which is ix. Then the middle term is negative 2 sine theta cosine theta, then integral of xy dA, which is the product of inertia p sub xy. This time I'll indicate that by product of inertia p sub xy. Then the last term is sine squared theta integral of x squared dA, which is iy. So I sub u equals cosine squared theta integral of y squared dA minus 2 sine theta cosine theta integral of xy dA, then plus sine squared theta integral of x squared dA. So again, integral of y squared dA is ix, then times cosine squared theta. This is product of inertia p sub xy. Then we have 2 pxy sine theta cosine theta, then plus this is iy, then sine squared theta. I sub u therefore equals I sub x cosine squared theta minus 2 times p sub xy sine theta cosine theta, then plus iy sine squared theta. So that is I sub u. Likewise, I sub v is integral of u squared dA, and u is quantity y sine theta plus x cosine theta squared dA. So following this pattern here, then I sub u equals sine squared theta ix, or ix sine squared theta, plus 2 pxy sine theta cosine theta, then plus integral of x squared dA is iy, so iy cosine squared theta. I sub v is ix sine squared theta plus 2 pxy sine theta cosine theta plus iy cosine squared theta. While the product of inertia puv is integral of uv dA, and u is y sine theta plus x cosine theta, and v is y cosine theta minus x sine theta. So this is integral of u v dA. Expanding, we have puv equals sine theta cosine theta integral of y squared dA, then minus we have sine squared theta integral of xy dA, then plus cosine squared theta integral of xy dA, then lastly we have minus sine theta cosine theta integral of x squared dA. So we note that this is ix, this is product of inertia with respect to the xy axis, this is product of inertia with respect to the xy axis, and this is I sub y. So POV therefore is equal to Ix sine Ix minus Iy, because this is Iy sine theta cosine theta, then plus product of inertia times quantity cosine squared theta minus sine squared theta. This one, if we factor out. Then using the trigonometric identities, sine 2 theta equals 2 sine theta cosine theta, then cosine 2 theta is quantity cosine squared theta minus sine squared theta, then cosine squared theta is 1/2 of quantity 1 plus cosine 2 theta, and sine squared theta is 1/2 of quantity 1 minus sine squared theta. To simplify these equations, then I sub u becomes Ix times quantity 1/2 times 1 plus cosine 2 theta minus pxy, this is 2 sine theta cosine theta, so p sub xy sine 2 theta, then plus iy, quantity 1 half, quantity 1 minus cosine 2 theta. So combining like terms, we have 1 half of ix, then 1 half of iy, then 1 half of ix cosine 2 theta minus iy cosine 2 theta. Then for the product of inertia, it is always negative pxy sine 2 theta. Therefore, I sub u is 1 half of quantity ix plus iy, then plus 1 half of I sub x minus I sub y cosine 2 theta, then minus pxy sine 2 theta. Similarly, I sub v from here is, we replace this by 1 half of 1 minus cosine 2 theta, then plus pxy sine 2 theta plus iy times 1 half 1 plus cosine 2 theta. So therefore, I sub v is 1 half ix plus 1 half iy, or 1 half of ix plus iy, then minus 1 half of quantity ix, because we have negative ix cosine 2 theta, so minus 1 half quantity ix, and this is positive iy, 1 half iy cosine 2 theta, so iv is 1 half of ix plus iy minus 1 half of quantity ix minus iy cosine 2 theta, then plus pxy sine 2 theta. So remember, p sub xy is the product of inertia with respect to the xy axis. So here I denote the product of inertia with p to, in order not to commit mistakes later, that we might miss one subscript, either x or y, so that might be interpreted as moment of inertia only. So to distinguish it, so I should put p so that it is understood product of inertia. Then for PUV, this is sine 2 theta over 2, so PUV, or product of inertia with respect to UV axis, Ix means Iy sine 2 theta over 2 plus Pxy times cosine 2 theta. So that PUV is equal to this expression here. So PUV is 1 half of quantity Ix minus Iy sine 2 theta plus Pxy cosine of 2 theta. So these are the formulas. These are the transformation equations for moments and products of inertia. So product of inertia, moment of inertia. So we need to memorize this. And if you can derive these formulas in the same manner as they are presented and derived here, then you can easily remember them. So again, I sub u is 1 half of ix plus iy plus 1 half of quantity ix minus iy cosine 2 theta, then minus product of inertia with respect to xy axis sine 2 theta. While I sub v is 1 half of ix plus iy minus 1 half of quantity ix minus iy, then times cosine 2 theta plus pxy sine of 2 theta. So that is I sub v. Then PUV is 1 half of ix minus iy sine 2 theta plus pxy times cosine 2 theta. So if we add I sub u and I sub v here, so this second term and third terms will cancel or vanish. Therefore, I sub u plus I sub v is simply ix plus iy as expected. So I sub u plus I sub v equals I sub x plus I sub y, or JO, or polar moment of inertia, with respect to the origin. So that's it. So to summarize the formulas, I want you to recall these formulas here. So I sub u is 1 half of ix plus iy plus 1 half of quantity ix minus iy cosine 2 theta, then minus pxy sine 2 theta. For I sub v, same terms except that the second and third terms will have opposite signs. So that when we add the two, the second and third terms will cancel. So I sub v is 1 half of ix plus iy minus 1 half of ix minus iy quantity cosine to theta plus pxy sine to theta, while p of v is 1 half of quantity ix minus iy sine to theta plus pxy cosine of to theta. And finally, that moment of inertia with respect to O or JO, or with respect to the origin or the polar moment of inertia, remains constant regardless of the angle of rotation, as long as the axis pass through, or the axes are associated with the same point O. Level 141, determine the moments of inertia and the product of inertia of the beam's cross-sectional area with respect to the U and V axis. So here is the even figure where theta is positive 30 degrees because it is counterclockwise from the x-axis. So for our solution, we have to recall the formulas first. I sub u equals 1 half quantity ix plus iy, then plus 1 half of quantity ix minus iy cosine of 2 theta minus pxy sine of 2 theta. So again, I sub u is 1 half quantity ix plus iy plus 1 half of quantity ix minus iy cosine of 2 theta plus px minus pxy sine of 2 theta. I sub v is 1 half of quantity ix plus iy minus 1 half of quantity ix minus iy cosine 2 theta plus p product of inertia xy sine of 2 theta. While product of inertia PUV is 1 half of quantity ix minus iy sine 2 theta plus pxy cosine 2 theta. So 1 half of quantity ix minus iy sine 2 theta plus pxy cosine 2 theta. So let's evaluate ix first, which is 3 times 6 cubed over 12 moment of inertia of a rectangle with respect to the centroid, and that is 54 inches to the fourth. Iy is 3 cubed times 6 over 12. 3 cubed times 6 over 12 equals 13.5 inches to the fourth, while product of inertia with respect to xy axis is 0 because the rectangle is symmetric with respect to the centroid, and the centroidal axis passes also the centroid. So pxy is 0. Substitute here. So I sub u is 1 half of quantity 54 plus 13.5 plus 1 half of quantity 54 minus 13.5 cosine of 2 times 30, so cosine of 60 degrees minus 0. So I sub u therefore is equal to 43.88 inches to the fourth. I sub v is 1 half of quantity 54 plus 13.5 minus 1 half of quantity 54 minus 13.5 cosine of 2 times 30 degrees, then plus 0 sine of 60 degrees, or 0 sine of 2 times 30 degrees. So I sub v is equal to 23.62 inches to the fourth. PUV is 1 half of quantity 54 minus 13.5 sine of 2 times 30 degrees, or sine of 60 minus 0 cosine of 60. So PUV equals 17.54 inches to the fourth. So that's it. Level 142, determine the moments and product of inertia of the quarter circular area with respect to the x prime and y prime axis. So x prime, y prime axis are treated as u and v axis. Rotation is 30 degrees counterclockwise, so that's positive. So for our solution, formula first, I sub u or I sub x prime equals 1 half of quantity ix plus iy plus 1 half of quantity ix minus iy cosine of 2 theta, then minus product of inertia xy sine of 2 theta. I sub y prime is 1 half of quantity ix plus iy minus 1 half of quantity ix minus iy cosine 2 theta plus pxy sine of 2 theta. Then pxy is 1 half of quantity ix minus iy sine 2 theta plus pxy cosine 2 theta. So from the figure, this is quarter circular arc, quarter circular area, so ix equals iy equals pi r4 over 16. Remember? Then product of inertia is with respect to xy axis. Ixy is pxy equals r to the fourth over 8, if you can recall. So again, theta is 2 times 30 degrees positive, so 60 degrees. Substitute I sub x prime equals 1 half of quantity pi r4 over 16 plus pi r4 over 16 plus 1 half of quantity pi r4 over 16 minus pi r4 over 16, so that would be 0. Cosine of 2 times 30 degrees or cosine 60 degrees minus r to the fourth sine of 60 degrees. R to the fourth over 8 sine of 60 degrees. So this part is 0. This is pi r4 over 16. So ix prime equals pi r4 over 16 minus r square root of 3 over 16 r to the fourth. Factoring out r to the fourth over 16, then ix prime equals quantity pi minus square root of 3 times r to the fourth over 16. Likewise, iy prime is equal to 1 half quantity pi r4 over 16 plus pi r4 over 16 minus 1 half quantity pi r4 over 16 minus pi r4 over 16 cosine of 2 times 30 degrees, then plus r to the fourth over 8 sine of 60 degrees. So the second term is 0, the first term is pi r4 over 16, the third term is square root of 3 over 16 r to the fourth. So iy prime equals pi r4 over 16 plus square root of 3 over 16 r to the fourth. Factoring out r to the fourth over 16, so iy prime is quantity pi plus square root of 3 r to the fourth over 16. And lastly, product of inertia px prime y prime is 1 half of quantity pi r4 over 16 minus pi r4 over 16 sine of 2 times 30 degrees plus r to the fourth over 8 cosine of 60 degrees. So the first term is 0 and the second term is cosine 60 is 1 half, so r to the fourth over 16. So px prime y prime is r to the fourth over 16. So that's it for this problem.